Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I am going to solve some numericals for you on the concepts of De-Broglie model. Before starting the numericals, let me write formulas for you for a little revision. So the very first formula that I am going to use over here to solve the numericals will be lambda is equal to the h upon m into v, where the h is Planck's constant, m is the mass of moving particle, v is the velocity of moving particle, and the lambda is the wavelength of the moving particle. The another formula which I am going to use over here is lambda is equal to the h upon 2 into kinetic energy into mass of the moving particle whole root. And the third formula which I am going to use over here is wavelength is equal to the h upon 2 q, the capital V and the small m whole root, where q is the charge of the moving particle, v is the potential difference, the capital V is potential difference, the small v is called velocity. Here the lambda is equal to h upon mv. This is the small v, that stands for velocity of moving particle. The capital V stands for potential difference that we have applied to accelerate that charged particle, and small m is the mass of the moving particle. So let me write it over here that small v is the velocity of moving particle and capital V is the potential difference applied to accelerate the charged particle. So these are the three formulas that we are going to use to solve the further numericals. So let's talk about the very first numerical. In the first numerical, the question is saying that a proton is moving with a kinetic energy of 5 into 10 to the power minus 27 joules. So here given thing is kinetic energy. The given is kinetic energy whose value is 5 into 10 to the power minus 27 joules. Kinetic energy is represented by E and the small k. We have to evaluate the wavelength of the proton. Now here the mass of the proton. The mass of the proton, we know that it is 1.66 into 10 to the power minus 27 kilograms. So the formula that we will use over here to solve the numerical is lambda is equal to the h upon 2 into kinetic energy into the mass of the proton. Here the value of Planck's constant h is 6.626 into 10 to the power minus 34. So let's substitute all the values in the formula. The wavelength comes out to be 6.626 into 10 to the power minus 34 divided by 2 into the kinetic energy is given, it's 5 into 10 to the power minus 27, and the mass of proton comes out to be 1.66 into 10 to the power minus 27 whole root, and this answer comes out to be, the wavelength of the proton comes out to be 1.66 62 into 10 to the power minus 7 meters. So this is the first numerical. Hopefully you all understood it. Please do have a look. Now let's move to the second numerical. Now second numerical is asking calculate the De-Broglie wavelength. We have to evaluate the De-Broglie wavelength of an electron traveling at the 1% of speed of light. We have to evaluate the wavelength of an electron traveling at the 1% speed of light. So first of all, what is the mass of electron? The mass of electron is 9.1 into 10 to the power minus 31 kilograms. Now what's the velocity of electron? Velocity of electron here given to be 1% of speed of light. 1% of speed of light, that is 1% of 3 into 10 to the power 8 meters per second, and it comes out to be 1 divided by 100 into 3 into 10 raised to power 8 meters per second, which solves to 3 into 10 to the power 6 meter per second. So we got the velocity of the electron. What's the value of Planck's constant? It is 6.626 into 10 to the power minus 34 joules second. Now the formula which I am going to use over here is lambda is equal to the h upon m into v. So wavelength comes out to be, what's the value of h? It's 6.626 into 10 raised to power minus 34 divided by 9.1 into 10 raised to power minus 31 into the velocity is 3 into 10 raised to power 6. The wavelength comes out to be 242.7 into 10 to the power minus 12 meters. So I got the wavelength of the electron. The De-Broglie wavelength of electron comes out to be 242.7 into 10 to the power minus 12 meters. So that's the second numerical. Please do have a look. Now let's move to the third numerical. Now the third numerical is saying the two particles A and the B are in motion. If the wavelength associated with the particle A is 5 into 10 to the power minus 8 meters, calculate the wavelength associated with the particle B if its momentum is half of the A. So first of all I am writing wavelength of particle A is given to be 5 into 10 to the power minus 8 meters, and we have to evaluate the wavelength of particle B. Now what's the formula? The wavelength of particle A comes out to be h upon m into v. Now m into v is called the momentum, so you can also write Planck's constant divided by momentum of particle A. The same way, the wavelength of particle B will be equal to the Planck's constant divided by the momentum of particle B. Now let's divide. Mark it number 1 and mark it number 2. Now divide number 1 by number 2. So the wavelength of A divided by the wavelength of B, it comes out to be h upon momentum of particle A into h upon momentum of particle B. So the wavelength of particle A divided by wavelength of particle B comes out to be momentum of particle B divided by the momentum of particle A. Now in question it is given that momentum of particle B is half of the momentum of A. So that is momentum of particle B is half the momentum of particle A, or you can say that 2 into momentum of particle B is equal to the momentum of particle A. So now let's substitute the value of momentum A over here. So after substituting, I got the wavelength of particle A divided by wavelength of particle B comes out to be momentum of particle B divided by 2 into momentum of particle B. So relation comes out to be wavelength of particle A divided by wavelength of particle B comes out to be 1 upon 2. So which implies 2 into wavelength of particle A is equal to the wavelength of particle B. Now in question it's given the wavelength of particle A is 5 into 10 to the minus 8 meters. So let's put it over here. 2 into 5 into 10 to the minus 8 is equal to the wavelength of particle B. So wavelength of particle B comes out to be 10 to the power minus 7 meters. So hopefully you got the third numerical. It was an easy one. Please do have a look. Now let's move to the fourth numerical. The fourth numerical is saying calculate the De-Broglie wavelength of electron that has been accelerated by 100-volt potential difference. So here is potential difference is given. So we are going to use the formula wavelength is equal to the h upon 2q the capital V into m whole root. Now what is given in the question? First of all, what is the value of Planck's constant? It comes out to be 6.626 into 10 to the power minus 34 joule seconds. What's the charge on electron? We are ignoring the sign. The magnitude of charge is 1.6 into 10 to the power minus 19 coulombs. What's the mass of electron? It's 9.1 into 10 to the power minus 31 kilograms. And what's the potential difference given in the question? It is 100 volts. So let's substitute all these values in the formula. So wavelength comes out to be, what's the value of h? 6.626 into 10 to the power minus 34 divided by 2 into, what's the charge? It's 1.6 into 10 to the power minus 19. What's the potential difference given in question is 100 volts. And what's the mass given in question? 9.1 into 10 to the power minus 31, and we have to take whole root. So the wavelength came over here evaluated to 1.22 into 10 to the power 1.22 into 10 to the power minus 10 meters. So hopefully you got the fourth numerical. Please do have a look. So now let's move to the fifth numerical. The fifth numerical is saying calculate the wavelength of 1000 kilogram of rocket moving with the velocity of 3000 kilometers per hour. Here the velocity. Firstly, velocity is given to be 3000 kilometers per hour. We have to firstly convert the velocity from kilometers per hour to the meters per second. So this will be 3000. How many meters are there in 1 kilometer? It's 1000. Divided by how many seconds are there in 1 hour? It comes out to be 3600. Now it is converted to meters per second. And this value comes out to 833.33. 833.33 meters per second. So we got the velocity to be 833.33 meter per second. Now What's the mass given in the question? The mass is 1000 kilograms. So we have to evaluate the wavelength. What's the formula for wavelength? Lambda is h upon m into v. So what's the value of h? It's 6.626 into 10 to the power minus 34 joules second. So let's substitute all the values in the formula. So wavelength comes out to be 6.626 into 10 raised to power minus 34 divided by, what's the mass of electron? 9.1 into 10 to the power minus 31. What's the velocity that we have evaluated? It's 833.33. So the wavelength here comes out to be 7.9 into 10 to the power minus 40. 7.9 into 10 to the power minus 40 meters. So I got the wavelength. So now let's come to the next numerical, the numerical number 6. Here the question is saying the sodium flame test has a characteristic yellow color due to the emission of wavelength of 589 nanometers. So the here wavelength is 589 nanometers. It comes out to be 589 is nanometers into 10 to the power minus 9 meters. Firstly, we have converted our wavelength to meters. Now here we have to evaluate the mass of one photon. So we have to evaluate the mass. So the formula is lambda is equal to the h upon m into v. What is the value of wavelength? It's 589 into 10 to the power minus 9. It is equal to, what's the value of Planck's constant? It's 6.626 into 10 to the power minus 34 divided by, what's the mass of electron? It's 9.1 into 10 raised to power minus 31 in sorry, yes, we have to evaluate the mass of photon. I mistakenly put the mass of electron. We have to evaluate the mass. The mass of photon we have to evaluate. What's the velocity of electron? What's the velocity of photon? We have to take the velocity of photon to be the speed of light, that is 3 into 10 raised to power 8 meter per second. So we have substituted the value of wavelength of photon, the h, the Planck's constant, the mass of photon we have to evaluate, and we have substituted the speed of light to be the velocity of the photon. So here the mass of photon comes out to be 3.75 into 10 raised to the power minus 36 kilograms. So we got the mass of photon. While solving this numerical, I have mistakenly substituted the value of the mass of electron in the mass of photon. So that's not like that. So it's like we have to evaluate the mass of photon. So that's an m, and we have substituted the value of velocity of photon to be the speed of light, that is 3 into 10 to the power 8. And after substituting all the values, we got the mass of photon to be 3.75 into 10 to the minus 36 kilograms. So that's all for today. These all were the numericals. I hope you all understood today's numericals. If any student wants to book a paid online one-to-one class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.